Hi class, today we're going to be having a more in-depth look at the Pythagorean theorem. It's been something we've been using all year and in algebra, but today we're going to go a little more in depth with it. So just a quick review, when we're talking about Pythagorean theorem, we're only talking about right triangles, and those triangles have two legs and one hypotenuse. And just keep in mind that the hypotenuse is always directly across from the right angle. They might not be always like in the same orientation, so just check for where the hypotenuse is. The Pythagorean theorem actually says that the sum of the squares of the two legs is equal to the square of the hypotenuse. And we're really used to saying a squared plus b squared equals c squared, and that's how it's just kind of been abbreviated. The place that actually comes from is, if you remember, we use capital letters to name points or vertices. Well, the A comes from the side opposite angle A. So they use a little lowercase letter to represent this whole length here. So another way of saying the length of BC is they just call it little a. And then angle C and side C will be opposite, and angle B and side B are opposite from each other also. So the biggest difference between this and what we've done in the past is the directions for these will ask for the exact answer, and when we give the exact answer we want to make sure that it's written in radical form. So that is a little bit of a difference. We're not just going to be rounding these off. So when I look at this triangle, I find the hypotenuse, that's the side that's opposite from the right angle. So these are my two legs on either side of that right angle. So I'm going to set this up. 7 squared plus 17 squared equals x squared. And I'll want to grab a calculator for this. And if you have your calculator handy, that would be awesome for when you're following along. I have a little bit different calculator here so I can type it all in together. So I'm going to type in 7 squared plus 17 squared, and the answer to that is 338. So I'm going to write down x squared is 338, and then when I take the square root, I need to think about what perfect squares go evenly into 138. And it might be helpful if you just go ahead, like at the top of your paper or something, and list those out. I know it's been a while since we've done this when we did the algebra review at the beginning of the year, but how to simplify radicals and not just change them to decimals. So when I list the perfect squares, 1 squared and then 2 squared, 3 squared, 4 squared, 5 squared, 6 squared is 36, 7 times 7 is 49, 8 times 8 is 64. What are we at? 9 times 9, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, etc. So we could keep going. I think most cases you won't need to go farther than this. What you want to do is you want to see like if there are any of those perfect squares that go evenly into 338. And because that is a bigger number, probably nothing just like jumps right out at you. I could be wrong, maybe one of those numbers do, but what I would do is I would just go to the calculator and start kind of guessing and checking. Okay, does 4 go into it evenly? No. And just go through your list and see which one does. So 338 divided by 16. Nope, not that one either. You might be able to skip some of them, like I wouldn't bother, dividing by 25 or by 100 or, things that you know are not going to work. Just to kind of speed this up, I'll tell you what goes evenly into it. 169 does. So I would set this up to where I would write down that this is 169 times 2, and the square root of 169 is 13. So the exact answer to this side here would be 13 times the square root of 2. And just so we can do this a little better, if you wanted to double check this, when you plug it in, you would have 13 times the square root of 2 squared. And if you were doing this on a calculator, you would want to make sure that you have it typed in correctly. If you actually grab your calculator now, you want that answer to be 338. And most of the time for most students, they don't get that the first time they type it in. So let me just show you how you can do that on your calculator. If you have one of them like mine, oops, that's not what I wanted to do. 13 times the square root of 2. You want to be squaring that number. So if you just push squared, it will probably give you the wrong answer. And in this case, yes, it does, because all they have you squaring is that square root part. So here's a couple kind of workarounds around that. You can either type in 13 times the square root of 2 and push equals, and you'll get this nasty decimal number. But then when you square that, oh, I guess this one here doesn't do it because it didn't square that exact number, it squared a rounded answer. But if you were to round this, it'd be pretty darn close. If you use one of my calculators, it stores all the digits in there, and that should give you exactly 338. Otherwise, a workaround for this is you could put it in parentheses. So 13 times the square root, oh, keeps wanting to do that. So I have to put on this one the multiplication sign. 13 times the square root of 2, and I think we're going to have to put some double parentheses around this, and then we want to square that. And yeah, now this gives me exactly 338, which is what I wanted it to be. So just a little calculator knowledge there. Make sure you try that on your calculator, because I'd hate for you to be doing all this work correct and then getting the wrong answer on your calculator. Okay, for this next one, these are my two legs. This would be C. It doesn't matter which one I call A and B. Actually, I'd almost prefer to have that switched around and say x squared plus 22 squared equals 25 squared. And again, we're going to be using our calculator. So let me switch back to that. Actually, let me go ahead and delete some of this stuff too. With this, what I would end up doing is, I know I'm going to be subtracting. I would probably just type in 25 squared minus 22 squared and just do all of that on my calculator at the same time. If you like writing out all that extra stuff, you can. But when you kind of go through this enough, I think you'll kind of get this figured out, that this x squared should equal 141. And then when you take the square root of each side, again, we don't want to just change this to a decimal. So I would come over here to the calculator and I would start dividing by perfect squares. So 4 doesn't work. Oops. Try dividing by 9. Nope, that one doesn't work. So 141 divided by 16. And you could go through the list, and I'll just give you a heads up. There are not any perfect squares that go evenly into 141. So sometimes you can't simplify it. So the final answer. Okay, so this next thing, this is more just for your benefit. You won't necessarily have to use them, but it might come in really handy if you do. They're called Pythagorean triples, and Pythagorean triples are whole numbers that are sides of a right triangle. And it's when all of the sides of a right triangle are a whole number and you don't have to deal with any radicals. You'll like these two because then you just get an exact answer and you don't have to worry about simplifying them. So some really common sets of Pythagorean triples are 3, 4, and 5, and 5, 12, and 13. So what that would mean is you'd have a right triangle and the sides would be 3, 4, and 5. And hopefully it's obvious, but that biggest number will have to be your longest side. So if you have something, maybe instead of having to like figure out all of the numbers if you have some of these memorized. Maybe this is 36 and this is 39. Well, if you had this next one memorized on the 5, 12, 13, this is just multiplying each of those by 3. So you might not have to set it up and get out your calculator. You might just think, okay, well, this is a multiple of a 5, 12, 13, and that's going to make this side, whoops, not 5, but 15, and you would just know that really quick, and you'd be able to just answer that question and move on. The place I see this the most helpful is on the SAT and the ACT. There was one year I was administering the ACT, and I saw, I think twice on the test, that some place within a question the Pythagorean triple was embedded. So if it's a timed thing like that, it might be helpful for you. If not, you can always use the Pythagorean theorem and go back and grab your calculator and do the work. That's kind of just, if you remember it, great, and if you don't, it's not a huge deal because you have something to fall back on. A very real world thing about the different ladder heights and how far up the wall they would reach. I hope you know this, but if you have a 20-foot ladder, you can't actually go 20 feet up in the air because otherwise you could easily fall back off the ladder. Maybe you've seen some clips of people doing that online. Not very safe. So let's read this. According to your company's safety regulations, the distance from the base of the ladder to the wall it leans against should be at least 1/4 of the ladder's total length. You're given a 20-foot ladder to place against a wall at a job site. If you follow the company's safety regulations, which you always should, what is the maximum distance x up the wall the ladder should reach? And they want us to round this one to the nearest tenth, because if you have this one in radical form, that probably won't be as helpful to you when you're talking about how many radical feet. It won't make as much sense as if you just kind of round that off. So it says here that this has to be at least 1/4, and there's probably a maximum distance too that they just didn't write in. So at least 1/4 would be 5 feet away, and these are your two legs. So I'm going to set this up as x squared plus 5 squared equals 20 squared. I can do this in my head. If you want to just use your calculator and just subtract them at the same time, you could do that too. This would be kind of showing more of the work if you need to do that. So I'm going to take the square root of 375, and I do not have that exact decimal memorized, so I'll pull up my calculator. The square root of 375 is approximately 19.4. So x is about 19.4, and I'm not remembering which letter that was. I think that was G. Yep. So that is letter G. So that would be your answer if this were the question. Again, you wouldn't probably want to simplify that and break that down. Again, that wouldn't make as much sense. So for story problems, we usually just change them to decimals. For everything else, especially if the directions say give the exact answer, they want it in radical form. And for this last part, the converse of the Pythagorean theorem, instead of starting out knowing that it's a right triangle and then saying that a squared plus b squared equals c squared, the converse would say if a squared plus b squared does equal c squared, so if you have all those sides and you know that first, then that will make it a right triangle. And not only will we be using that, but we will be telling if it's acute or obtuse also. So if a squared plus b squared is greater than c squared, it's an acute triangle. And if a squared plus b squared is less than c squared, it's going to be an obtuse triangle. And I remember the first time I saw this, I thought this was a little counterintuitive because I thought greater than should be obtuse and less than should be acute. But if I do a quick little example of, let's just say, equilateral triangle, which is definitely going to be acute, I think you'll see why. If I square each of those and add them up, you can tell that that is going to be much greater than that third side squared. So this is an example of an acute triangle versus something that's obtuse. You know, maybe this side's 11 and this is 6 and 6. Well, when you add those up and square them, so it's going to be 36 and 36, that's going to be less than that other side squared. So that's obtuse. So if you can't remember which one's which, maybe if you just kind of sketch out a little equilateral triangle, that will help spark your memory as to which case it is for each one. So answering these questions, before we do that though, we need to make sure that we determine whether they can even be sides of a triangle to begin with. And then if it can be a triangle, we need to tell if it's acute, right, or obtuse. So I made this big note. This is going back to lesson 5.5. If you need to reference that, I'll do a quick little review over here though. In order to make something be a triangle, remember we did some investigations with this. When you add up two sides, they have to be more than that third side. So I'll just write, actually I should write the sum of any two sides has to be greater than the third side. And that is not talking about when we're squaring the sides, because when we're squaring the sides, they could be equal or they could be less than, but just when you add them up before you square anything, any two sides have to be greater than the third side in order to make it a triangle. Again, that was lesson 5.5 if you need to refer back to that. So before I plug this into the converse of the Pythagorean theorem, I'm just going to check 11 plus 61 is definitely greater than, 11 plus 60 is greater than 61, so I can check it out. And just make sure that your biggest side is C, because otherwise it's not going to work out right either. And in this case, they have them already listed smallest to largest. So I'm going to write 11 squared plus 60 squared, and I don't know if it's equal to 61 squared. I'm going to figure that out. So it's calculator time. I'm going to go ahead and grab that. I hope you guys can see this okay. So 11 squared plus 60 squared, and that is 3,721. And then grabbing the calculator again, when I type in 61 squared, that is also 3,721. So because those are equal, I know that this is a right triangle. For this next one, this is another one where you really have to make sure you can use your calculator properly. Before I do anything else, I need to check and see if this is a triangle, and because I think most of us, if not all of us, are not super familiar with how these look when they're in radical form and knowing the exact length of those. So I'm going to just check and see, and I'm going to give approximations for these. So 2 times, no, I keep doing that wrong, 2 times the square root of 3 is about 3.5. If I do, and I'm just going to kind of remember that, if I do 4 times the square root of 2, so that's like 5.6. So when I add those together, the first one was 3.5, this is about 5.6. I'm up to about 9, just over 9 with those. So those need to add up to be more than this third side squared. And in fact they do. And this also just shows me that this one, oops, this one is my largest one, so that's C. So when I set this up, 2 times the square root of 3 squared plus 4 times the square root of 2 squared, and I want to see how does that compare to 3 times the square root of 5 squared. And I am putting these in parentheses on purpose because I want to make sure that I have this typed into my calculator right. So this first one, kind of like I said before, I would recommend doing the double parentheses. 2 times the square root of, nope, 2 times the square root of 3 squared is exactly 12. And you need to make sure that you have that exact number. And if you don't, either pause the video and ask me right away, or put a big question mark next to this one and I can help you with it when you get to class tomorrow, because I want to make sure you know how to use your calculator properly. So this is 12. The next one here is going to be 32. And then this last one is, let's see, 45. But looking at this, when I add those up, I get 44. And since 44 is less than 45, I know that this one is an obtuse triangle. Another way that you could come up with these if you didn't have a calculator is, if you remember, you need to square each part. And this is really what I do. I just kind of do it in my head. But we have 2 squared, which is 4, times when we square 3, we end up with 3. So this is 4 times 3, which is 12. For this one here, I have 4 squared, which is 16, times the square root of 2 squared, which is 2, and you have 32. And then the last one, 3 squared is 9, square root of 5 squared is 5, and that's how you get 45. So either make sure you know how to do it on your calculator, or you can do these in your head. It doesn't matter to me as long as you're able to get the right answers. Okay, and then for this last one, again, we need to make sure that these even make a triangle first and foremost. When I add these two numbers together, that's actually exactly 20. And because 20 is not greater than 20, I don't even have to go any farther because this one here is not a triangle. So it can't be obtuse or cute or right. So that's that. We'll practice this in class, and I hope this is very helpful to you. Have an awesome day.